Alright, good morning. Today we are gonna hopefully finish chapter 6, entire chapter 6 by finishing 6.5, continuing solving trig equations. This was the last question we solved yesterday, right? It was a quadratic equation involving cosecant. We will solve a similar question like that coming up, but we can just continue solving more, okay, today. And our next question is 3 secant square minus 4. Again, this is quadratic because we have a square. However, one level easier, I feel, because you don't have two separate with secants as before. Look, this has two spots with cosecant. And this is a single secant. I believe you don't need a substitution here. You don't have to flip secant by u like we did yesterday. So you can get to secant isolated easily, okay, without any substitution. So again, solving a trig identity requires isolating the variable, isolating the trig function first, and then figuring out this variable using the wheel of common values of sine and cosine on this picture. So how do I isolate this guy? 3 secant square minus 4. Get secant alone. Right, add 4 and get rid of minus 4 and divide by 3, get rid of that coefficient 3, right? So I'm first adding 4, cancel out. We get 3 secant squared theta equals 4. Next, I divide both sides by 3 and get secant squared theta as 4/3. Well, still secant is not alone. It's not been isolated, right? So what shall we do? How do you get rid of that square? Yep, we take square root of both sides. And secant theta is, okay, I can take 4 out and make this 2 root 1/3. But when 4 comes out, it becomes 2 and this drops to 1. However, we do not like ratios in the denominator or inside a radical. This is actually 1/3 if I pass root to the top and bottom. Root 1 is 1, root 3 is just root 3. And I rationalize this. Or no, I don't want to do this because I just leave it like 2/√3 here. Why? Because I'm not happy with secant. I'm not comfortable finding values of secant here. So whenever I see secant, cosecant, I feel like we need to flip them. If we flip them, we will no longer have that root in the denominator. That's why I stopped rationalizing it, because I'm going to flip secant. So let's flip secant. What happens if you flip secant? This is actually 1/cosine, so I'm going to flip it to cosine theta equals, so I'm flipping secant into 1/secant, which is cosine, and I need to flip this side too. It is √3/2. However, I have made a mistake. I missed a spot. Not a big mistake, major mistake actually. But well, where is that mistake? Yeah, there's a mistake. Focus here. Yes. When I take square root of both sides, we not only have a positive solution, it may be negative as well. Take a square root, always put plus and minus, okay? So there are two solutions you need to look up here. One, cosine theta. For what angles cosine becomes root 3 over 2, positive, sorry. For what angles cosine becomes root 3 over 2 or cosine theta becomes negative root 3 over 2. And you need to look up angles, good news, only from 0 to 360. You don't have to do 2 and pi thing, okay? So again, let's look up root 3 over 2. Which x coordinates have root 3 over 2? 1 and 2, right? What angles are those? Pi over 6 and 11 pi over 6. Okay, what angles provide x coordinate to be negative root 3 over 2? What are they? This, right? 5 pi over 6 and 7 pi over 6, right? Are these all from 0 to 2 pi? Yes. So we are all set. All you need to do is just enter these values into the box. Alright, in integers or simply, okay, they want it in any order, right? I will still put them in ascending order anyways. It's pi over 6 5 pi over 6 7 pi over 6 11 pi over 6. Alright, there are 4 solutions. Any questions? Alright, next. Wow, what a mess. Here are the differences in this question. First off, we don't have a single type of trig function here. How many different types do you have? I have a sine x, cotangent x. I can't solve two trig function once. I can't unless you split them apart. You separate this equation into two simple equations of their own, zeros on the other side. So that's a clue I'm giving you. Two trig functions can't be done at the same time unless you simplify. Yeah, you may change and simplify possibly. I don't know if you have a trick for that. Sine and cotangent cancels to 1, maybe. Then you're good, but otherwise you need to separate them. Okay, I want to hear from you. What do you suggest? Our objective in all of these questions is again get the trig function all by itself, either sine x equal to a number or cotangent x equal to a number. Unless you do this, you can't get the solution. Alright, so you need to get these guys separated and isolated. Any ideas?
Could you change cotangent into cosine over sine?
Of course, no problem. Let's change cotangent into cosine over sine. Both cotangents? Okay, all done. Next. Yes, I can. Cancel one from here, one from there. So all I have on the left side is 4 sine x cos x minus cos x sine x. Yeah, I'm stuck. Next.
Can you cancel the other side?
No. This sign you mean? With this? No, this sign is only multiplying these two. These two are multiple. This sign is not multiplying this one. I could cancel them if this was the case. If this sine square would multiply this one, yeah, I could, but no, I can't. Look, do you quit? Okay. Alright, let's not change cotangent to sine. Unless you want to continue. I don't know. There are multiple ways to solve a question. Maybe you see something progressing from this. Do you? I want to quit too as well then. Let's not change cotangent. Try some other trick.
Wait, add cotangent.
Add
Add,
cotangent and cotangent.
not just the one cotangent, base minus cotangent. Can we add cotangent with the other side?
Oh, okay. So you want to send the cotangent to the other side.
Yeah.
Like these two cancel. Okay.
So if you were dividing, if you were to divide both sides by 4 sine squared x, could you say that then the 4 sine squared x was equal to 1 because cotangent over 1 is just itself? So like if you had like 4 sine squared x cotangent x equals cotangent x now, and you were to say that like could you divide both sides by 4 sine squared x, and then you'd say that cotangent x equals cotangent x over 4 sine squared x. So then you'd say that the 4 sine squared x has to equal 1 because.
Okay. I think
Could you
I
do
got
that?
what. So why don't you
Yeah,
do this then?
Divide by cotangent.
Divide cotangent x both sides and get the
Let's
same
say that
result.
equals 1, yeah. That's a good
Okay.
Like I said. I think I just complicated it, but yeah.
I like the idea, but if you divide an equation, you're in an equation solving question. If you divide both sides with a variable, you are butchering the equation. You are you have a very fruitful big tree. You're cutting the big main branches off, and the tree will be less fruitful. You know. So this is what I mean. Yeah, this is done a lot. Like x squared minus x equals 0, right? When I say solve this question, one idea everybody likes is put x to the other side. These two cancel, kind of like cotangent. You're putting cotangent on this side, and then people divide both sides by x. Yes. And look what we got, x, and this side is only 1. You think you solved the equation. Yes, you did. However, you only solved half the equation here. You lost one possible solution by dividing both sides by x. So what is the proper way to do this? Never divide both sides with variables or trig functions. Always factor. Factor this. What do you see when you factor it? Two pieces. X is common. X minus 1, right? And I break each piece and set it into 0. So this is one solution. This is another solution. Look, this time I kept the entire unity of the tree. I didn't cut off branches or anything. And I got 2 fruits out of this tree. Whereas earlier we lost one of the valuable fruit, x equals 0. Okay? So here is the lesson we got here. You kind of going to the right solution, but when you divide both sides by cotangent, you lost main branch of the tree equation. Okay, so this is dangerous. You will only get half the solutions. Alright, so let's not send cotangent to nowhere. Keep it, but you're on the right track. Instead, you want to get rid of that cotangent next to sine square. Factor it. Look, isn't cotangent common in both sides here? Call it out. Factor cotangent out. Look what you have. 4 sine squared minus what? 1. Now this is a factored equation. You can set each piece into 0. Cotangent x is 0. 4 sine square x minus 1. Same result we got, but we didn't lose the other branch. Look, the other solution is still present. Same thing, right? Okay? Now, let's handle this side. For what values of angles here? Cosine, this is cosine over sine, right? Ratio of these two coordinates become 0. So cosine x is the x coordinate, sine x is y coordinate of these point x and y. You divide one into another and it becomes 0. What angles do that here? Right. I know you don't see that here, but this is the first one. First thing comes to my mind is, oh, there is a 0 here, maybe it's 0 angle, but no, this is cosine, here is sine, 1 over 0 is undefined, so it's not this one, it's this one, because cosine is 0, sine is 1, 0 over 1 is 0, so cotangent 90 is 0. So you found pi over 2 as x. Do we have more though? And this one too, 3 pi over 2 as well. Cosine is this, sine is that, cosine over sine is 0 as well. There are 2. Okay? How about this one? This one needs still work. 4 sine squared is 1 divided by 4. Look, you can divide both sides of an equation with numbers, but never with variables, okay? And I will take square root of both sides and do my common mistake, which is, what is the common mistake I keep doing all the time? Plus minus. So you will collect all x values. I don't want to split this into 2 parts. We can do it all at once. Collect all points with x coordinates, either negative 1/2 or positive 1/2. There should be 4 of them. What what y coordinates make 1 over 2 or minus 1 over 2? I think this one, 1 over 2. I think this one, 1 over 2. Negative 1 over 2. Negative 1 over 2. There are 4, right? 30, 5 pi over 2, 7 pi over 6, and 11 pi over 6. It's the same as earlier answer, right? So there are 6 solutions here. Wow, such a big solution set. 4 coming from this, 2 more coming from there, 6 in total. Okay, I'll leave this typing to you, okay? 6. I want to make 6 ratios now. Okay? How about this question? Alright, if there are multiple trig functions, sine and cosine, different trig functions, it's a good idea to try to factor them, if possible. Can you factor anything here? First one is sine squared, the other one is cosine. I don't see nothing common. So, but you need to factor. You can't solve this like that. It's a must. It's not optional. Factoring is not optional. We must factor it. And I don't see nothing common because first trig function is sine, second function is quite different, cosine. If they are not like, is there a way to make them like? Is there any way you can convert cosine into sine or sine square into cosine? I think there's a way. How do you make when you don't like sine or cosine into another? Especially if one of them has a square. We need to make one into another, guys, and I need help. Look at your trig identity sheet. There must be an identity relating sine square or cosine into each other.
You could do sine squared equals 1 minus cosine.
Right. We have most famous trig identity, Pythagorean identity, sine square plus cosine square 1. But I need cosine square, this thing converted into cosine square. So I will isolate this by sending cosine square to the other side and use this right here. Okay? So it is twice 1 minus cosine square x minus cos x plus 1. Is that right? So it's 2 minus cosine square. Agree? So I have 2, 1 adding to 3 minus cosine squared minus cos x equals 0. Agree? Maddie, what's wrong?
That 2 through 4, 5.
Right. This 2 multiplies both terms. Sine square replaced by 2 terms. That 2 belongs to both terms now, so you need to pass that 2 to the cosine as well. So there is a 2 missing here, minus 2. The part 2 times 1 is 2, and adding 1 and getting 3 is still correct. This is part, this is 3. Alright, good news. You have a quadratic equation with single variable or cosine. Just imagine this question as minus 2 u squared minus u plus 3 now, guys, and factor it. Or flip all the signs. This is plus, because I like working with positive squared term. So I'm flipping all signs to opposite. Can I do that? Can I flip one side of the equation all signs to opposite? Is it allowed? Yes. I'm just multiplying both sides with negative. If I multiply 0 by negative, it's still 0. But if I multiply negative 2 by negative, positive, negative by negative, positive, negative by plus 3 is negative. I like working positive too. That's why I'm doing this. There is no other reason. Now, can you guys break this into 2 pieces? Just imagine this is u. This turns into u then. So we have the variable u. How do you break it? I believe the first pieces will be 2u and u, right? So it can make 2u squared. Question is, what will be these two pieces? So when I multiply, it's gonna make minus 3. When you foil this, add outside and inside terms, we will get positive 1u. What's the right way to break minus 3?
2u plus 3u.
Saying plus 3 and minus 1. Let's justify. 2u minus 1 makes minus 2u. 3 and u makes 3u. And you add outside and inside terms, do you get the middle term? Yes, we do. That's the right way to break it. Okay, once you break, you put each side into 0, set each part into 0. Great. And isolate. Isolate u's, please. We get u equals negative 3 halves, and u equals 1. Well, wait a minute, we are not solving for u's in this question, we are solving for cosines or x's. So we need to revert this back to cosine x. And this one is another cos x. And so okay. Is everything I did clear so far? Let me go back and give you a moment to think about this. I have changed sine square into cosine square, passed the minus 2, collected numbers, switch sign, and I'm imagining cosines as u's. U square minus 2u squared and minus u plus 3. We broke it apart and set each part into 0. And then once you get solved for u, go back to original variable. U was just a placeholder, temporary replacement for cosine. So time is up, go flip it back to cosine. We did. Now it's time to decide what angles once entered into cosine makes it minus 3 halves. What other angles makes cosine 1? And for this stage, I believe you need the wheel. What points, which points here have x coordinate as negative 3 halves? Which ones? Here and there. So I got two solutions. 5 pi over 6, 7 pi over 6. Agree? Right?
But those are square roots.
Oh yeah. Yeah, I was testing you guys. Right? I'm glad you caught it. I'm imagining this square root, but no. This is a number, negative 1.5 in decimals, and no real value can go that far. Real values are limited to minus 1 and 1. So cosine never obtains this value under no circumstances. So no solution. Alright, however, can cosine become 1 sometimes? When? Here you go, I caught 1 here. Is there more? Okay, I see two angles though here. 0 angle or 2 pi. Which one are we gonna consider? Which one? Is it 0 or 2 pi or both? Which one? Tough question, huh? What does this say? Not including 2 pi. So your dilemma has been resolved. You can't consider 2 pi here, only 0. Okay? Alright, we're good. It's just single solution here. Did we get everything right? Oh, it was 0. I did not put 2 pi. Yeah, it's fixed. Alright, ready for the next one. Okay, I'll give you a couple minutes to think about this question. Hint, you need a hint, because although these look like same type trig functions, they look alike. Actually, no, they're not like. This is twice the questioned angle. This is 4 times the angle you're supposed to find. They are not the same trig functions. So you cannot combine them until you make them one kind, one same amount, either 2x or 4x. So you either need to make this 4x, raise it to twice the angle, double the angle, keyword double angle, or you need to reduce this to 2x, get the half angle, angle reducing formulas. That's enough hint. Angle reduce or increase this to 4x. Either way works. Your choice. Take a moment, think about it. There are multiple ways to go in this question. Alright, let's hear from you. Which option did you guys pursue? Which one did you change? Okay, let me give you the impossible way. Can I make this half angle like this is 2x, cosine 2x into 4x? Like this is half, this is always twice of it, right? Like if this is 2x, isn't this 4x? So can I change cosine 2x by plus minus square root 1 plus 4x here and make 4x that way? It looks like it's working. Cosine 2x becoming cosine 4x is twice, look, twice the angle, half angle formula. However, there is an issue that we have a plus minus. Which one are we going to choose? Because we don't know the location of the quadrant of the x to pick one. We need to use both. Second, I hate radical square roots. Square roots are a challenge to work in equation solving questions. So this is the worst idea. Don't use it. What is better way then? Try to increase this to 4x. Try to decrease this to half the quantity, 4x to 2x. Look, this is the formula to change 2x to x. This is 2x to x. How can I change 4x to 2x? If this is 4x, these will be half of it. 2x, 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 2x. Do you see that? Do you see that? Good. Now there is another issue waiting for you. Which one of these 3 options shall we use? Again, this is the trick I'm making. If this is 4x, these will be 2x and 2x as desired. I will change this into 2x. But which one in the list? Option 1, option 2, option 3. Which replacement formula I'm going to substitute here? First, second, third. Which one makes most sense? Do you want to take the first one? Cosine squared 2x minus sine squared 2x, and then this guy? Is this a good choice? Why not? Why don't you like this? Or why do you like this? Yeah, we do not like variety, diversity in equations. I want everybody to be the same color, same type. Sine and cosine couple? Nope, that's not good, guys. How about the second one? 1 minus 2 sine squared 2x. Do you like that? Again, too much diversity. 2 different things I don't like. Now we are doomed to use the last one then. 2 cosine squared 2x minus 1 plus cosine 2x equals 0. This makes most sense. Okay? It's single type, cosine 2x all over the place. I think we can do this. First off, can I flip these two locations, minus 1 to the end, cosine to the bottom? Because I like the constants on the last part for a reason. Now imagine cosine as u, cosine 2x. Cosine 2x's are all gone, u replace them. What is the first term gonna be? 2u, cosine 2x replaced by u, u minus 1 is still minus 1, correct? Correct? Yeah, it should be square. This is square of cosine, so it should be square of u. Alright, let's break this again. It keeps becoming the same equation, right? Somehow, maybe this number changes, but we always have 2u. So it's 2u and u. Help me figure out the missing parts. Come on, how many different ways you can break 1? Minus 1. It breaks as 1 and minus 1, right? You don't have a choice. Really? You have a choice. This is the wrong pair. Why? When I FOIL outside terms and inside terms, what is the sum? 2u minus 1 makes minus 2u. 1 and u makes 1u. The total is it positive 1u? No. Wrong. Right pair, wrong replacement. Minus 1 should be the left, positive 1 should be the right. Look, make this minus, make this plus. Now all fixed. This is positive u, this is minus u, the total is positive 1. Great. Okay, doc. 2u minus 1 set into 0, u plus 1 set into 0. I have u is 1 over 2, u as minus 1. That means cosine x is 1 over 2, cosine x is minus 1. Go take your wheel and find those angles. Agree? I have a mistake. Where is it? Where is my mistake?
Cosine 2x.
Yeah, this thing, u was placeholder for not cosine x, it was cosine 2x. This is 2x. Alright, so what can cos 2x's will be? There is an angle called 2x. You enter it into cosine and it makes 1 over 2. What angle or angles are those? Here is one, right? Here is second. There are 2. So it is pi over 3 or, what was that one? 5 pi over 3. Now there are angles called 2x. You enter it into cosine, it makes minus 1. What angles are those? Angle or angles? There's only one, I think, right? Which is this guy. Pi, correct? Agree? Okay, what is x here then? Divide both sides by 2. Pi over 2. They are not looking for 2x. They are asking us to figure out x only. Oh, we're in trouble. There are more. There may be more. Since now we are dividing both sides by 2, you need to consider now 2 n pi's as well. Okay? So it's not only pi, when you take pi, it's correct. Plug in now 1. It can be also 2 pi more. Divide 2 pi more, it's 3 pi over 2 can be as well. Can I add 4 pi and divide by 2? No, if I do 4 pi, it becomes 5 pi over 2. 5 pi over 2 is out of range because they want in number 9, 0 to 2 pi. And when I do go add 4 pi to my solution, n equal 2, I'm out of range. So no, let's stop at 2 pi. So there are 2 solutions. So this is even I'm prone to miss this part. Okay, it's either pi or you add one more 2 pi. You get 3 pi and divide by 2, 3 pi over 2. There are 2 solutions from this direction. How about this? You need to add also 2 pi to these guys. 2 pi. 5 pi over 3 and 2 pi. Because you can take one more turn and divide by 2 and it still falls into an angle between 0 and 2 pi. Okay? So I'm adding another 2 pi, and now we need to divide everything by 2. Take half of it. And x will be, what is pi over 3 divided by 2? Pi over 6. 5 pi over 2 divided by 2 is 5 pi over 6. This thing is, first set the common denominators, then divide by 2. 7 pi over 6. And this thing is, set the common denominators by 3. 6, 11 pi over 6. Am I right? 11 pi over 6. Can I go add 4 pi to this? I did 2 pi, 4 pi? No. When I do 4 pi and divide by 2, this angle is more than 360. They are only expecting an angle from 0 to 2 pi again. 0 to 2 pi. So be careful. Always having 2x or more x's inside is tricky. Are we good? Wow, how shall we enter all this now? I really want to check. So let's do it. And pi over 2, was it? And 3 pi over 2. Check. Good. Okay. Alright. If you noticed, I put a third set of formulas. Maybe you could use some product formula, section 6.4. I wonder how we could use this in this question. Do you have any idea? So we did double angle formula. That's one solution. half angle formula didn't even work. I'm saying you may possibly use sum to product formulas from 6.4. What do you think? Alright, computer is failing. Yeah, think about this. How can I use this set of formulas into this here? Yeah, this is a cosine of apples, cosine of oranges, like cosine x plus cosine y. We can turn it into product. Why is product superior than additions? Why do you want to change it into product? Because if you have product of two cosines, you can split and set each piece into 0. Look, I can't set each piece into 0 with sums, but if it is a product, I compute these angles and set each piece into 0. Alright, I lost that formula, but I hope you still have it. Okay, we said cosine of x plus cosine y is twice, what was it? Read it to me. X plus y over 2 times x minus y over 2. Good. So both cosine. Alright, what is our x? Let's call these u and v's because x and x confusing. U and v is uv, u minus v. Our u is 4x, so just switch. So cosine 4x plus cosine 2x is twice cosine of the first plus second divided by 2 times cosine of the first minus second divided by 2 equals 0. Oh, look at this. 4 plus 2 is 6 divided by 2 is 3x. 4 minus 2 is 2 divided by 2 is just cos x. Now, since this is a product, I can set each part into 0. Like it's factored. When you factor, you are allowed to break each part into their own zeros. And I can divide both sides by 2 and get rid of this 2, right? So it's cosine 3x equals 0. Now tell me, which angles on this wheel makes cosine 0? Which angles is that? What 3x angles make cosine 0? Pi over 2 and 3 pi over 2. But not only these, I need to add 2 pi to them, or maybe 4 pi as well. If I do 4 pi, they are still, when I divide by 3, they are still in the range, right? I pick the pair from 0 to 360 first, and then I add another 2 pi and another 4 pi and take again. So because I'm going to divide them by 3 and they will still fall on that range 0 to 360. So this way we get 1, 2, 3, 4, 5 solutions. No, it should be 6. 1, 2, 3, 4, 5, 6. Yeah. X is these values. Alright, what is the other one we need to look at? For what values, oh again this is the same. For what values cosine becomes 0 again? It's pi over 2 and 3 pi over 2. You don't have to add 2 pi because if you add 2 pi it's going to be out of range, but you already counted these in here. You don't have to double count. So this direction didn't give you any new results. Did we get the same results though? Pi over 2, 3 pi over 2. This is gonna be, no, pi over 6, 3 pi over 6. In other words, it's pi over 2. And I think the others will be the one of the 6, okay? So if you cancel and simplify, they will match. Okay? So that was sum to product formula application. I don't know which way you like better. Alright, coming up next. Let me give you a hint. This question number 10 and this question are similar. Look how similar they are. Sine cosine pair, sine cosine pair. This one is harder. Why? What was the beautiful side of this question? Why this one was easier? Because around the sine, what do you have? Look, a square, and I used Pythagorean identity 1 minus cosine squared to change this guy into this, right? You don't have that square to make the change. So don't even dream about using this identity, because this identity for squares, I don't have the square. I don't have squares around sine or cosine. I wish one of them had one. If you don't have a square, can you create a square? In this question, we need to start with squaring both sides. In an equation, you can square both sides, but warning, danger. When you square both sides of an equation, you are possibly creating fake solutions that may not satisfy the original question. How come? Let me give you an example. I'm calling x equal to. Let's square both sides. Shall we? Let's square. I'm squaring both sides. What happens? What is 2 squared? And I change my mind. Oh, I want to go back to original x. What operation do you do to go back to x? Square root. When you go back to original x to cancel square, when you introduce square root, you get plus and minus in front. Look what happened. You can no longer go back to x. It is 2 or minus 2. You started with single x equal 2, You created two different solutions. You created a fake one. Real one is this. So you did actually in the background same deal here. There were only maybe 3 angles satisfying this. Now you created 6. How do we get and pick them out later? We will test them. So once you get your solution, test if there are any fake ones. Okay? So you do this always when you square both sides of an equation. You do this for caution. There is a danger. I put the mark. We will check it later. So how do you guys square 1 minus sine x? Oh, it's the square of the first and square of the second, right? Is that so? And this one is cosine squared. Agree? Yeah, it will be positive when you square minus sine x is positive. Agree? It's a trap. This is not how you square differences. If you have 2 times sine x, yeah, that's how you square it. You square the first, you square the second. This is a subtraction, or 1 minus sine x. When you have a minus b, how do you square a minus b? Or x minus y? You need to repeat it and FOIL it. You need to FOIL this thing. There is no shortcut, I'm sorry. 1 plus sine square was wrong. 1 times 1 is 1. 1 minus sine x is minus sine x. Minus sine x times 1 is minus sine x. Minus sine is positive sine squared. We were right about 1 and sine squared, but there are 2 more terms. Actually, there is one term. When you combine this, it turns into minus 2 sine x plus sine squared x. Okay? Next. What is next? Now you have your beautiful squares. Why did we try to get these squares again? You have your beautiful squares all over the place. Why did we do that? What was our purpose? What was our thinking? Why do I need the squares? Aren't we happy with sine and cosine? Come on. You know it.
Can you switch to cosine squared x to sine?
Yeah, to make all these one of a kind. Sine and cosine variety is bad. We need to convert one into another, and we want to pick cosine as 1 minus sine squared. Because there are 2 sine x, they are hard to switch to cosine. There is a single cosine versus to these guys. It's easier. Cosine squared is 1 minus sine squared. And put everything to the left. Take these to the left. So you get this beautiful equation. Look at this. When I put 1 to the left, it turns into minus 1. And when I put minus sine squared to the left, it turns into sine squared. Always move things to the left and keep the right side 0. Watch. Perfect. Alright. What is next after this? You have a single type of trig function in the equation. Single type trig function. So it's ready for action. What action? This looks very similar to one of the questions we saw. Where did we get that? Yeah, it kinda looks this, but not really. It kinda looks this after cosine sine squared flipped into that. But I want you to figure out what's next after this. It's because it's ready, it's cooked, ready to serve. Here's what I propose, and you judge. This time, I'm adding sign to both sides, dividing both sides by sign. Actually, 2 sign. Why don't we kill that 2 as well? Oh, look what's going on. These are all cancelled into 1. You have only sin x left here. All done. Happy? Are we all happy? Question over. Almost over. You just need to figure out the angles making sine 1 now, right? Yeah, it's still bad. Trust me. I did a bad thing. We shouldn't be dividing both sides by variables, especially trig functions. So if dividing both sides was bad, what was the other way? What was the exit solution for that? What did we do back then if dividing was bad? What's the alternative? Factor. Factor, factor. Factor, what's common between these guys? What is it? Sin x. Not only sine, it's actually 2 sin x. 2 also common. So if I borrow 2 and sin x here, it's actually negative 1 left on this guy, right? Negative sign left. And if I borrow 2 and sin x, it's sin x left. And now I can set each into 0 because this is a product. When things turn into product, you feel free to split into their own zeros. Now I can divide both sides by 2. And voila, we have 2 simple equations to figure out what angles under sine makes it 0. There aren't too many. 0 and pi. What angles make sine to be 1? Pi over 2 only. Right? Go look up from the wheel. I don't want to waste time on it. Okay? 3 solutions. 0 pi, 0 pi over 2 and pi. All in this requested range. Oh no, I forgot to check something. I told you, I promised you there are fake ones inside. So how can I figure out the fake ones? Let's plug in 0 first. When I enter 0, does it make left and right matching? Is 0 satisfying this equation? Why? Sine 0 is 0, 1 minus 0 is 1, cosine 0 is 1. Yes. The first one checks out. How about pi? Is sine pi okay? I'm sorry, pi. Plug in pi here and there. Sine pi is 0, 1 minus 0 is 1. Cosine pi is, what is cosine pi? Look up from this. It's, oh my god, pi is not satisfying it. Although I found it correctly, it's not because I squared both. I created fake ones. How about pi over 2? I think pi over 2 is good. Yeah, pi over 2 is good. So there are 2 solutions, not 3, 0 and pi over 2. Alright, there is one question left. I want you to take a look at that over the weekend. What was it? 0 and pi over 2. No, Friday I think. But 11. Yeah, we'll start with this next time.